So we have started with our second lesson, that is force and laws of motion. Now in the force and laws of motion, I think I told you about what is force. I will just repeat it once again. Force is that vector quantity, okay, which can change the state of an object. It can change a body at rest. It can change the state of rest of a body to motion. It can bring an object in motion to rest. It can increase the speed of an object. It can decrease the speed of an object. It can change the direction of an object. It can even change the shape of an object. So force is that vector quantity. You have already seen this in our live class, but I am just repeating it once again. Then I think I told you about balanced and unbalanced forces. Balanced forces are those forces which cancel each other and do not bring about any change in the state of an object. Now, for example, one example we can give is of the tug of war. In the tug of war, both the teams will be pulling the rope, but sometimes the rope neither moves left side nor right side. So this is because both the forces applied by both the teams will be the same and they cancel each other because they are in opposite direction. Just like plus 3 and minus 3 cancel each other to give 0. Okay, and the second example I gave you of an object kept on the ground. On the ground, if an object is kept, okay, gravitational force is acting on it, the force of the air column above it acting on it, then even the wind is acting on it. But all of these cancel each other and hence the object does not move. This is an example of balanced force. Then unbalanced forces. Unbalanced forces are those forces which can bring about change in the state of an object. Because unbalanced forces are those forces which do not cancel each other and hence they bring about change in the state of an object. Okay. Now example of unbalanced forces is when you push your friend. Okay, your friend moves further. Or else when you kick a ball, it moves, right? It starts moving. These are all examples of unbalanced forces. Then I think I told you about Newton's first law of motion. So what is the definition of first law of motion? Every object continues to be in its state of rest or of uniform motion until it is acted upon by an unbalanced force. Then the examples we gave was a book kept on a table remains at rest until an unbalanced force acts on it, this one. And second one is a ball kept on the ground remains at rest until someone really kicks it or some unbalanced force acts on it. Now these are the two examples which I gave for what you can say Newton's first law of motion. If a question is asked, state and explain Newton's first law of motion, then you should first give its definition and then give these two examples to explain what is Newton's first law of motion. Okay, so we will just move further in this lesson. Now we will see the next term, that is inertia. Inertia means it is the inability of an object to change its state of rest or of uniform motion along a straight line. So what is inertia? Inertia is the inability of an object to change its state of rest or of uniform motion. Now inertia, it depends on the mass of the object. Okay, it depends on the mass of the object and inertia is directly proportional to mass of the object. Okay, inertia is directly proportional to the mass of the object. And what is inertia? Inertia, it is the inability of an object to change its state of rest or of uniform motion. It depends on the mass of the object. It is directly proportional to the mass. The greater the mass, greater will be the inertia. Lesser the mass, lesser will be the inertia. Now write down these notes, okay? So what did I say about inertia? Inertia it is the inability of an object to change its state of rest or of uniform motion along a straight line, right? So now we will see some examples of inertia. The first example is when the bus suddenly moves forward, the passengers are pushed forwards or move backwards. This is because the passengers are at rest. Okay, the bus starts moving, but the passengers are unable to change their state from rest to motion suddenly. So they move backwards. Later on, they also start moving with the bus. And second is when a moving vehicle applies brakes suddenly, the passengers move forward. This is also an example of inertia. This is because when the bus or the vehicle is moving, the passengers are also in motion. But when the brakes are applied to the vehicle. The vehicle comes to rest, but it takes some time for the passengers to come to rest. That is why they move forward. And when the brakes are applied, you can see the upper portion of the body moves forward, not the feet, because the feet are in contact with the moving vehicle. So they change their state along with the vehicle. Okay, it takes some time for the upper portion to change its state from motion to rest or from rest to motion. That is the reason why when brakes are applied or when a vehicle moves forward suddenly, it is the upper portion of the body which either moves forward or backward. Okay, so these are examples of inertia. The third example of inertia is in activity 9.2. See here, activity 9.2. What is given here is that activity 9.2 is you have taken a glass and on the glass you have placed one smooth cardboard and on that you have kept a coin. And if you suddenly flick this cardboard, okay, the cardboard moves forward whereas the coin drops into the glass. And coin drops into the glass, this is also because of inertia. Because the cardboard was at rest, you have flicked it hard. So it moves, but it takes some time for the coin to change its state. That is the reason the coin falls down. This is also an example of inertia. Okay, so and we'll see further questions on inertia on page number 118. So we'll see the first question, in text question on page number 118. I will read the question. Which of the following has more inertia? A rubber ball and a stone of the same size. The answer is stone, because stone has more mass. Always remember, more the mass, more will be the inertia. Since the stone has more mass than the rubber ball, stone will fall, stone has more inertia. Then B1 is a bicycle and a train. Train will have more inertia because train has more mass, more weight. A 5 rupee coin and a 1 rupee coin. 5 rupee coin will have more inertia because 5 rupee coin is heavier than 1 rupee coin. Now second question is, in the following example, try to identify the number of times the velocity of the ball changes. A football player kicks a football to another player of his team who kicks the football towards the goal. The goalkeeper of the opposite team collects the football and kicks it towards the player of his own team. So we'll see a football player kicks a football to another player. This one time the velocity will change. Second is the player of his team kicks the football towards the goal. The second time the velocity changes. Then the goalkeeper of the opposite team collects the football and kicks it towards the player of his own team. So again, third time, the velocity of the ball will change, or speed or velocity of the ball will change. So in this example, the velocity or speed of the ball will change how many times? 3 times. First, it changes when a football player kicks the ball to the player of his team. Second, the player of his team kicks the ball towards the goal. Second time it changes. Third time, the goalkeeper picks it up and kicks it. Third time, its velocity changes. So, and here the football's velocity changes 3 times. The question asked here is also identify the agent supplying the force in each case. Agent supplying the force in each case is the players. The players apply the force in each case. Now please don't just listen to this. Write down these answers also in your fair book. Now third question is explain why some of the leaves may get detached from a tree when we vigorously shake its branch. Okay, when the branch of a tree is vigorously shaken, the leaves were earlier at rest, but you are actually changing the velocity of the branch. Okay, it will take time for the leaves to change its, what you can say, state of rest or motion. So when a branch is shaken vigorously, okay, some of the leaves get detached. This is also because of inertia. Okay, when a branch of a tree is shaken vigorously, some of the leaves get detached. This is also because of inertia. Now write down these answers. Don't just listen to what I am saying. Now fourth question, why do you fall in the forward direction when the moving bus brakes to a stop and fall backwards when it accelerates from rest? This is also because of inertia. These examples I have already given to you. Okay, so all of you please write down these examples in your fair book, and then all these notes whatever I told write them in your fair book. Practice them by learning and writing without looking. Okay, bye for now.